And this was designed to obtain a scheme to IALA Category 1 standards. 3 rig watchers will be deployed, 1 on each substructure, with 1 unit containing a RACON. This provides for interlocking redundancy, and the lights are also synchronized to enhance the conspicuity of the field. The satellite location at MCPO1 has a rig watcher deployed with dual equipment, which will give inbuilt redundancy. So it has 2 lights, 2 sets of battery banks, 2 sets of satellite monitoring. The ongoing site management is such that there will be 4 rig watchers deployed at any one time, with 4 replacements on standby. Each unit is monitored daily, supported by an annual visual inspection. It's planned to exchange the rig watcher units every 4 years, and importantly, the responsibility for the provision and maintenance of the ACE navigation on these sites will lie with Total E&P in perpetuity, as it will with any oil operator who is decommissioning platforms. The responsibility lies with them. So in summary, the decommissioning of offshore oil and gas platforms creates a man-made hazard to navigation which must be addressed. Solutions have been developed to IALA standards to maintain the navigational safety. It is anticipated that the concrete in the legs and caissons of these extraordinary structures will continue to harden for the next 500 years. I trust that the advances in ACE navigation technology will surely make the marking of these hazards easier in that time. Thank you very much.
Okay, thank you very much, Mike. Now, let's see Malcolm, if we can make it this time. Malcolm Nicholson, please.
Looks like it's going to work. I have a slightly alternative presentation for you. Thankfully for you, it's a little bit shorter, and hopefully by now you'll have forgotten most of what Seamus said, so I'll be able to reinforce some of his points. The primary purpose of ACE navigation is to provide information to the mariner. The buoy is there to mark a hazard or a channel, and it does this by a distinctive set of characteristics, such as a colour scheme, a light flashing. A radio aid, such as differential GPS, broadcasts fixed information, such as its ID and its position, using a specified frequency. It also provides varying information in the form of correction data for the satellite system. The overall aim of the Aid to Navigation service should be to get all these forms of information to the user as quickly and as reliable as possible. Now, when I read about this conference, it said a global approach. All waters, all risks, all solution. As usual, a very ambitious topic for IALA, which I'm sure has been achieved with the quality of the presentations given so far. I might be able to change that. But in order to try and answer this question, I think it's important to say, how did we get here? What happened on the way? And where are we going next? So in order to answer these questions, with regard to the role of visual aids to navigation, aid navigation, I'm going to give you a brief history of how we got here, and then I'm going to cover 2 areas in more detail. The first being the synchronization of lights, and secondly, aids to navigation as information systems. So, how did we get here? Well, as Seamus alluded to in his presentation, the network of lighthouses around the UK coast were developed so at any one time entering UK waters you could see 2 lighthouses, and therefore you could triangulate your position. Buoys and beacons mark dangers such as wrecks, rocks, outcrops, shallow water. Along with that, radio navigation developed, with radar being introduced a long time ago now, the development of a global navigation satellite service and its differential service, and more recently AIS, which has led us to look to combine all these elements into the inception now of e-navigation. Well, what happened on the way? Well, advances in lamp technology meant that they lasted a lot longer, they were a lot more reliable, they were a lot brighter, and their power requirements had come down. This meant that we could automate lighthouses, make them automatic, and they became reliable. And once they were automated, we had, I shall have to be careful here and say no use for lighthouse keepers, but there was no requirement for them anymore, so they became unmanned. Once they became unmanned, they needed to be monitored, so we were able to keep abreast of what was happening and ensure that the light was on via a reliable monitoring system. At the same time, elements of radio navigation were increasing and improving with the further development of satellite systems, which James alluded to with the GLONASS and Galileo compass. And ultimately, all this has led to lots and lots of information for the mariner. I think this has been well established now that the amount of information available to the mariner on the bridge of a ship is somewhat overwhelming. Well, where are we going next? Well, we've all heard that there's increasing numbers of larger, faster ships, and we do recognise that GNSS is now the primary fix for positioning purposes. But with these increase in larger, faster ships, there has been an increase in buoyage, as the mariner does require a short-range visual confirmation of his position. During the last 4 years, we've heard that IALA and the A&M committees and the other committees have updated the MVS, and you'll see a copy of that here. And this is all the tools we can use in our toolbox to overcome short-range problems such as background lighting when entering large ports and harbours. This slide here is a typical port entrance, and I want to enlarge this slide and just to give you an idea, because I'm going to go on and talk about synchronised lights here. I'm not a mariner myself, but I would find this kind of approach quite daunting. And to try and pick out some of the individual aids would be quite difficult. Okay, that didn't work. But it was meant to show the impact of synchronised lights and them all coming on together. After the Shanghai conference, there was a lot of talk about synchronised lights and their deployment. We, in the GLER and RNAV section, had a bit of a brief, incidentally from Captain Glass, to have a look at these things and highlight any concerns that we had. The first immediate concern was if you're going to mark a channel such as this with synchronised lights, the first issue you're going to have is if you add red and green lights together, they appear white, as in the middle of this slide here. So one of the things we wanted to determine was a minimum angular separation, or how far they needed to be apart so they didn't appear white. To that end, we held a viewing trial which consisted of 11 very notable experienced mariners, and we held this trial in the evening when it's dark over a distance of 5.5 kilometres. And then we separated the lights by half a minute of arc until all 11 observers could clearly see the two separate red and green lights. And that distance was